Dear participants, very good evening. Welcoming you all for the sixth day International Research Methodology course on Spss and Academic Writing. And we are in the last day for Shobna ma'am. And remaining 4 days will be taken care by other resource persons to talk on the particular topic. It starts from what was that publication to open access. We have various resource persons there. So today is the last day for Shobna ma'am. So requesting you all to pay much attention for the class. And if you have any doubt, you are most welcome to contact us. Definitely will help you. And if you are plan to have any kind of sessions on SPSS or data analysis, you are most welcome to contact Shobna ma'am on online. She was not able to come to offline since because she is from Mumbai and she is doing the PhD also. But for online program, definitely if she is free, definitely she will be coming and do the needful. Currently, she is being the resource person for ROSA workshops as well as ICSR workshops. She was highly engaged participant, but anyway, in the means of education, definitely she will be able to help you uh, in the progress of SPSS as well as data analysis. And sincerely welcoming you all for the sixth day of this international research methodology workshop. And without taking much time, let me hand over the session to Shobna ma'am.
Thank you, sir, and good evening, everyone. Once again, to this 10 days international workshop on research methodology, data analysis using excellent SPSS and academic writing. And welcome you all for the sixth day of my session. Um, Hope you all have been actively doing all the tasks and noting all the key points so that in future you can utilize that for your uh, research works. So today, in continuation of our yesterday's session on SPSS, so we will be seeing today data analysis, that is our hypothesis testing, parametric and non-parametric using SPSS. So this is the overview of today's session. We will introduce or we will go through all the statistical tests, few statistical tests I mean, which is more commonly used in the research paper at the start level. And as already mentioned, I will be giving you one data set. Sir has already shared with you. We will be working on that with different possible tests for the given demo data. So these are the parametric tests what we have seen in what we have tried in Excel, and usually it assumes to be normal. That is, the assumption normality should be satisfied. Since it is an assumption lying distribution, if the normality assumption fails, of course, we have seen that chart of hypothesis testing. The non-parametric test is the alternative for that. So, for example, t-test, independent t-test, pair t-test, ANOVA. These are few alternative tests which are non-parametric, which are useful for ordinal data or small sample. Uh, Generally, what it is seen that the data is small. If it is quantitative and data is small, it is not normal generally. And if the data is large, we have an assumption that if data is large, it is assumed to be normal. That is what uh, this written in bracket. Usually normal. Why it is written in bracket? Because this one thing to be noted here. When the data is large, it is assumed to be normal by fault. And 30, more than 30 is known as large sample in statistics. 30 or more than 30 is considered as large sample. If less than that, if it is small sample, then you have to check the normality. If it fails, then we go for the non-parametric. Or if it is ordinal scale also, the non-parametric test is used. So here is the data set overview, which is already shared with you. You can try to first understand the data set. So 90 subjects, I mean 90 participants have been taken here, which is of three groups, A, B, C, each of 30. So group A having 30 response, group B 30 response, and group C 30 response. We are having before after data of, and that is the score of that respondents. Then we are having three different scores: condition 1, condition 2, condition 3. That is at three different condition. They have been examined and they have got a score. So same person, one is after some program, that is pre and post, we have taken in data. One is called as repeated, that is repeat, we have repeated the test under three condition, that is condition 1, condition 2, condition 3. Then later there is a category like yes or no classification. Just like an example, like an example of giving a choice. Okay, just your random data has been collected here for your make you understand how this analysis can be worked on here. Okay, and one more data is there, response, a binary outcome, that is again like two outcomes, positive or negative. That can be the result, we can say, of any particular test whatever is been conducted over here. So this is what the data I was talking about, which is already shared with you. So group, a simple score, then a before after score is there, then score with at different conditions of test, then a category and a response. So here I have tried to cover different types of data so that uh, maximum possible tests we will try to perform. Okay. We can transfer the data completely from Excel. So I'm going to open the data. You will go for the location. It is asking you the question. Read variable names from the first row of the data. Yes, because first row is having the column heading, right? Yes. And this is the sheet. Okay. So you can see directly you will get the complete sheet here from Excel. You can import to SPSS. And you can see in variable view, by default it must have taken all the data types and the scale to some extent. If you want to change or anything, we can, and accordingly we can proceed further. Okay, so you can complete this step. So now let us see, uh, take few questions. This is the first question. Is there a significant difference in the score between group A and group B? This is your first question. Is there a significant difference in the score between group A and group B? You can kindly make a note. So here, why there is two tests mentioned? I think you must have understood by at this point now. If it is parametric, then we go for independent t-test. That is, if it assumes the normality, then independent t-test, of course, it's a sample of 30 plus. So by assumption, we can consider that it is normal. But if the sample size was say less than 30, then we have to go for Mann-Whitney test if it fails the normality. Okay, if it fails. So I will show you both the things and in SPSS, so that later when you will be working in your case, you can accordingly, now you know how to check the assumptions, right? So you can go accordingly and you can choose one of them. But here I will show you both the case, even if it is normal or not normal. I will perform and show you both the case, so that you can go ahead accordingly based on the assumption. So here, is there any significant difference in the score between group A and group B? Total we are having three groups. Here they are taken only two groups and they want to know whether there is a significant difference. Hence, we are going for independent t-test. Now, if it is independent t-test, our hypothesis word will be considering the word mean difference. There is no significant difference how we used to write. That is, it is generally tested for the mean, right? That is what it is written. The mean of the score is same in group A and group B. Same means no significant difference. That is the another way of writing. Yes. And the mean of the score differs between group A and group B. But when you are going to use the non parametric test, it doesn't have the parameter like mean and variance, right? Hence, we have to not use or we cannot use the word the mean score is same, the mean score is different while performing the Man Whitney test. In that case, we have to use the word distribution, or we can use the word median. Okay, so the distribution of score is same in group A and group B, or the distribution of score differs between group A and group B. So this step is clear to you all, when to use mean and when to use distribution. Okay, so this is what is the difference you should know uh, when you are concluding this session at end. Ki independent t-test comes under parametric, so the parameter mean is used. If it is not, Man Whitney is the alternative of independent t-test, and there we have to use the word distribution. So coming, just kindly make a note of this, then I shall go to the SPSS. Okay, so let us see the analysis part. So here we are having group A and group B and C. Okay. Okay. So when you go to analysis, so since we know that independent t-test is for means, of course you will get in the option of compare means in the tab under analyze. So in that independent sample t-test, independent sample t-test. So now I have not done any changes in the data. As the data was in Excel, I have put in the SPSS and we are just continuing. Okay, while performing, let us see what are the difficulties we may come across depending upon the data types. Okay, that hence I made it clear in the last session all about that. But as you're doing for the first time, just when you're getting the raw, start and just see where you're facing the difficulty first. Test variable will be what? The variable I want to test. So I want to test the variable score. Okay, so I will take score in the test variable. Grouping variable. So my groups, right? It's very clear here. My group will be grouping variable will be group. And here it is asking me define the groups. Okay, it is asking me define the groups because it can take only two groups, right? So even if there is two group, it will ask you what is define the group. So A and B, right? According to my data set, A and B are the group. Continue and just for option if here nothing to be done, by default everything is there. And okay, see, it has taken only group A and group B. So just perform this and get ready the output. Then we will discuss about this output in detail. So perform this, everyone. Matlab those who are actually doing the spaces along with me, you can perform. Others, you can just note down and roughly make the tables so that whatever I'm explaining the keywords, you can mark it down and make a note for your later requirement. So we are done with this, right? And you all have got the output. Let us now try to understand the results what we have got. So first thing, of course, the summary is given, the count 30 30 in each group, the mean score of each group, the deviation of each group, and standard error mean. Coming to the next table, the table actually which we want, which will be helping us to make the conclusion for our claim. In the first column, you can see the two rows written as equal variance and assumed, equal variance not assumed. Can you all recall something after reading this? Which we have seen in Excel also this while performing independent t-test, that is two sample t-test, isn't it? So same way here also, because that is the part of t-test. It is not like Excel and SPSS software, okay? It is the concept for the t-test that we have to check. So hence here automatically it gives both the things by default. It has both the option given equal variance, assumed, equal variance not assumed. You are having a significance value just next to that. Leaveness test for equality of variance. That is what our F test, what we have done in Excel. Check the significance value. P value is less than 0.05. We reject the null hypothesis. And here P value is more than 0.05. So we do not reject the null hypothesis. And the null hypothesis is what? Variance are equal. And hence here you will consider the further table p value of the first row, that is variance are assumed equal. Further you can check the df value also. Check for unequal variance, our df is not as the required. What should be the df in this case? N minus 1 and n minus 1, right? So n minus 1, 30 minus 1, 29, and again 30 minus 1 for group B, 29. So 29 plus 29 is 58. So that is how also it is verified that the first one is, that is assuming equal variance is the considered one. And the significance value 0.07. See, it is not necessary you will get the same significance value. In this case, it is, but not necessary. Okay. So the significance value 0.007, which is less than 0.05. So we reject the null hypothesis and we say that the mean score is different for group A and group B. So the mean score differ between group A and group B. Hope this is clear to you all. Just you can note it down what all you want to note down. Then if you're having any doubt in this, you may ask.
Ma'am, I have a question. The question is that if, for example, the equivalent variance is not assumed, then the mean difference will show different here or it will show the same.
No, you have to, if we get the p value less than 0.05, then we will come to a conclusion that equal variance is not assumed. So in that case, you have to take the corresponding significant value for t test to make the conclusion.
Okay.
That is the second row. Okay. We will also see, I have shown you now A and B now. Just we can try for B and C, what is the difference, and A and C. Let us see what is the difference in the other tree combination also as a practice.
Right, ma'am.
So let me now perform and show the rest two also we will see. So same procedure we are going to do for now. We have to change only the group. We will define now group A and group C. Okay. Okay. So again for group A and C also we are getting a p-value is greater than 0.05. So assuming equal variance here also. Okay. So p-value is less than 0.05 for the t-test equality of means. So reject. That means the mean score differs between group A and group C also. And you can see the difference is there a lot. The mean is 48 and the mean of C is 62. And what was for A and B? For A and B is 48 and 56. Let us check the third option also, third combination. B and C. Continue. Okay. So here too, it is assuming equal variance. So in short, we are getting when we are taking A, B, C, D, A, B, C, it's coming as differs, the score differs. So we can see the mean score everywhere. It's almost like 48, 56, 62. So there is difference in the mean score between the three groups too. Okay. So this is how it is performed. And we can use it for the interpretation part. Okay, so moving to the next, if it was not normal, or if it is small size, and if the normality assumption was not satisfied, or if this score was in an ordinal type, then the suitable would be Mann-Whitney, right? So let's see how the Mann-Whitney test is processed in this. So analyze. We are having a different option, separate category for non-parametric test. In that, one sample, independent sample, related sample. So independent t-test is for independent sample, right? So that means Mann-Whitney is also under independent sample only. There is legacy dialog where you can see the names individually here. Okay, can you see the names here individually? Chi-square, binomial, run, one sample KS, two independent sample, K independent sample, two related sample, K related sample. Okay, so here if you want to select by in this say case, so it will be two independent sample because it is exactly two independent sample. Now when I clicked this test, what difference you can see here? When we had taken the case of t-test and over here, what is the difference? Under the base list of variables, we could see only the scale type of data. Scale means the numerical type of data. Data type which was numeric, only that is been visible here. So test variable, I can add over here, but for grouping variable I need what? The group which is not visible over here because the data type is not numeric. So if I want to perform the Mann-Whitney in this order, grouping variable, that is it should be entered the data in form of numerical form, which I showed you in the last session, where satisfied, dissatisfied, we typed 1 2 3, and then I renamed what is that. So here if I want to perform, then I need the grouping variable also to be a data type of numeric. Hence, at this stage, we cannot go ahead for Mann-Whitney U-test because the data is not as per the required format. So hope this is very, very clear to you all. So in SPSS also, for parametric and non-parametric, the data type matters. Now coming to one more way, analyze non-parametric independent sample, this option. Okay, so here in field you can see all the list. So this is what we have to very carefully note. If you're going in that option in that way, what is the required type of scale, that only it will consider. In that, then only you can perform ahead the next step. So this is the alternative way for that, by going directly to the non-parametric option in that way, not by legacy dialog. In this test field, I will put the score, and here you can see all the type of data is visible. In groups, I will add the group, and in settings, here by default what happens now, see, I will not do anything. By default it will only select which test is more suitable for that group. Okay, but in our case we need only between A and B, right? If I am not selecting any option, okay, I am not selecting any option and I am just clicking the option called as automatically choose the test based on the data. So any guess, participant, whether it will perform Mann-Whitney? Mann-Whitney is the alternative of its t-test. That is, Mann-Whitney is used for 2 sample. But here we are having 3 sample. So when it is 3 sample, for parametric, we have to go for ANOVA. For parametric, we have to go for ANOVA, right? So what is the alternative for ANOVA? It is Kruskal-Wallis test. It is Kruskal-Wallis test. Okay. So if I am not selecting any option, and in setting we have right, so automatically choose the test and run, it will perform and show you the suitable one. It will frame the hypothesis also. See, when it is non-parametric, it will automatically choose the hypothesis wording as distribution. The distribution of score is same across category of group null hypothesis. Now we have to assume it as same. And alternative will be the alternative sentence of that. So I didn't test. We didn't select the test name, right? But observing the data, understanding the data by itself, it selects and it has selected the correct one, Kruskal-Wallis test, because it is having 3 groups. It is having 3 groups. Hence it has selected by default Kruskal-Wallis test. Hope you're understanding how much simple it is making for us. But the thing is, you should structure the data properly. Okay.
Ma'am, can
Now
you
come.
repeat this specific option from where you have taken this from the menu?
uh, in analyze, non-parametric. Are you getting this type of symbols, ma'am? Uh,
Yes, fine.
in that independent sample. So
Okay,
in that
thank you.
field, first you will select the required things, test score I want to set, and groups. And in setting, generally by default it would be automatic choose only. So now we are not doing anything, let it be automatic choose, just to see how it was performing, taking the correct option. Okay, and just run.
Ma'am, I have just one question that now with the automatic chosen test, it was able
Mm.
to perform the test. But
Yes,
before,
yes.
when even if the data was not in a correct
Huh.
format,
When I want to go
before it
by that option, because that we are doing manually, right? In that option, it will not it able to read the data which is in string form. For that particular type of go, the data should be in the format of scale only. So we have to enter all our data in terms of scale type. That is numerical type, I mean.
yeah, that's fine. But in automatic, that condition is not there.
No, not yes, not there. It's not there. You have seen this field option, ma'am. Just see the field option. It is showing your. Just unselect this group. Can you see in that group? It is showing here. It is ready to take all the type of scale, ordinal, nominal, also the scale one. That is the
Yeah.
numeric one. Yes,
Okay, ma'am. Thank you.
that is what this flexibility is there. You. Okay. So now let us go for the setting and change the test. That is customize test and compare mean with man Whitney. Let's see what it is going to do here exactly. Okay, let us see here man Whitney U test and run and see what message it is given. Unable to compute because our data is in one particular column where we are having three groups in that same column A, B, C. Hence, we are getting the message as unable to compute. So that much well it is designed because it is understood conceptually, right? If it is three group, we have to go for crucial values. So even if you take a wrong option, you will not get an answer. Then accordingly, you have to structure the data. So if you want to go for man Whitney for this data, then you will create a separate species sheet where you are going to have only two groups of data. Only two groups of data and its respective score, and you can perform. Okay. And of course, here I want.
Ma'am, I have a question that in terms of quality perspective and in terms of quality of data computation, which one would you recommend? Should we do auto or should we, because auto is a very easy option. We don't have to, you know. So I was just thinking whether which option is better.
Ma'am, in this choosing, of course, it will not make the mistake because if you're going to take man with me, of course, you are choosing a wrong option, right? Because
Yes.
I'm having here three groups. And in spite of that, if you're going to choose man with me, that means you're chosen wrong option, hence it is not giving you the answer. So in that case, preferring the appropriate one, it's not harm in that. They're choosing the by default one.
Okay, ma'am. Thank you.
The what more change you can do over here is suppose if you want some other test, then you can customize. Otherwise, you will go for automatic choose. But see, not always it will choose the correct automatic because this is one I have showed you. Mostly it would be right only, but it is rare case it may get confused key what also it will list all the possible tests and among them you have to choose which is the best correct one. That also happens in automatic. Okay, but in this case, if it is three groups, there is no other options. It should be crucial values. Either you select or the system will select automatically. The only option is crucial values. Hence, we got the answer to be crucial values.
Okay, so which means that the possibility, if the groups are more, the possibility is that even the auto can go wrong. You have to use your judgment, right?
Most probably it will not go wrong. But in that
Mhm.
case, you should also have the understanding that whether it has taken the correct one.
Okay, ma'am. Okay,
We
thank you.
can't blindly rely on that because there is only one option of crucial values there, so it may not go wrong in this case. But there are other tests, so many tests, right? There you have to have an clarity whether it has taken the correct option. I am just making the group name in numbers because I want to show you that one more way of also performing. Okay, as we did in t test, we could define without making any change in the data set or without creating a new SPSS sheet. We were able to define the groups in t test, right? A and B, B and C, uh, and A and C, whatever group we want, and we were able to get the answer. But here, uh, no, because in that customize in that field, it has a setting. So for using that setting, our data should be in that format only. Hence, we couldn't do the Man-Whitney U test over here because of the three groups together in one column. But when I was going to the one more format, that it is asking my numerical data, right? So now I'm making the groups to be numeric in the last column. So I will take all my group A to be 111, group B to be 2, and group C to be 3. So you can do this. You can type the data in Excel. You can drag and you can copy paste also here. You can make the necessary changes in the variable view. I am going to write it as group only, but group underscore in num, that is, it is in the number form, numeric 0. I am not making any other change. Of course, in this case, my numeric is in the form of nominal. Okay, it's not scale, it's not ordinal. My measure is nominal here. That is 1, 2, 3 is just a identification for that group. Okay. Now coming back to analyze. Let me first perform, then you can, I'll give you few minutes. You can just then do accordingly. Let me just explain you. Now you can change the, see the difference in this. Now I'm going to the legacy dialog, two independent sample, and I have got the score in my test variable. And now can you see the grouping variable where I want to select the group? I have got the group number which was in the format of numeric. Earlier it was in string, hence we couldn't get that option. Now I had typed in form of number, and I had taken it as nominal scale. You can give that labeling all except values later on, but now without doing any extra, I have just added the numbers and I'm showing you. It is asking me define the groups. Is it similar to the independent t-test, the way of asking the question? Okay, so this is what the difference between that earlier Man-Whitney U-test, that is a field where I cannot customize because the data was in one complete column. Even if here it is in one complete column, I can customize it as per my requirement by taking only two groups at a time, and define the group accordingly if it is in the required format. So hence the data entry in SPSS is very, very important. So mostly it is preferred to be numeric. That is what you must have now understood. Scale you change, nominal, ordinal, but the data entry first, the beginning, is preferred to be numeric. That is what you must have been heard few words from the expert that data coding is going, matlab entry is coding is going on in SPSS. So this is what that coding is. Coding means not typing anything. You are adjusting you're decoding it according as per the requirement. So group 1, group 2. Continue. Man Whitney by default it is selected. Okay. See, now you got the output. The only thing is you will not get a very beautiful tabular form as we got for the Kruskal values over here. Okay, if you want in this type, then you have to go by that option. But if you are interested only with our answer, not of any decoration is required. This is our test statistics. Man Whitney U test, and my p value is 0.009, which is less than 0.05. So we reject the null hypothesis and we say that the mean score differs. Right, the distribution of the score is differ between group A and group B. It's very clear to you all the difference between t-test and Man Whitney when we have to go. So I'm showing you, and the difficulty what you faced when the data type is not as per the requirement, then how you have to change it. And if you want to do by this method only, then you have to make a separate sheet and take only the two groups so that you can perform and see. Automatically it will give you take the correct one. If you want, I will show you that also. Okay, I will show you that also. Now I will take only two groups. Only two groups. A, B, data. Okay, I'm taking only A, B. I'm taking a new sheet. I'm pasting here. I'm writing the variable names over here as group. And here I'm writing as score. Okay, score is scale. Okay, all fine. I have taken only two groups now. Now as the decorated form table, analyze, non-parametric, independent sample, field you have to take it properly, score in the test field, group, in the groups, setting, I'm not doing anything. I will go for automatically choose the test based on the data and run. And see here. Now it is not showing the error that unable to process. Now it has correctly written the hypothesis. The distribution of score is same across the category of group. Test used is independent sample Man-Whitney U test, because it knows that if it is two group, it is they are asking to check the difference only and significance value, and it also gives the decision. So if you are unable and to perform in the second way and defining the groups in numbers, etc., in that view of seen in numbers you have to define, then you have to define the group accordingly. Here what you have to do is you have to make a new sheet. So either way you have a different job. The thing is which one is comfortable for you and which is overall you feel that want the presentation also, you can go accordingly. Okay, but the thing is you should understand what type of data should be there and how the data should be structured. So both the side it is having a different type of way of data to be presented to use the same test. Both the side we have performed Man-Whitney in two different way. In one way it is asking that it should be in numerical data type, and it is giving a tabular form the significance. If I wanted in terms of this presentable form with stating the null hypothesis, test name, decision, etc., then I have to go for that automatic form, and that the data should be in a required form. Then only I can perform. So both has its own limitations, and you should practice and have a clarity so that you are ready to do it in any of the way. Hope this is clear, participant. Anything you want to ask based on this, you may. Okay, fine then. So we can move ahead. And one more thing, in this data sheet, where we have entered the new column, that labeling part you can do. Right, yesterday I had shown you in values, you can do that. 1 means A, 2 means B, and 3 means C. Okay, you can do that. But it will be in numerical form only, the variable, because our original way is numeric. Okay, only the presentation way is ABC. I'll performance show you again in this case. Numeric, legacy dialog, 2 independent, grouping variables. Now if you want to see between group 1 and group 3, continue. Okay. Now, can you see the difference in the output? Earlier, I didn't give the values. So, it was showing me 1 and 2. Now, I have given the values. Why I want to show you this? When you are not giving the values, the third person who is going to see, he or she might be not knowing what is the meaning of 1 and 2. So, hence, that is the purpose of giving values. So, here I have given the values. Now, you can understand, okay, the 1 means A and 3 means C. That is how the change purpose of labeling values, giving the values. Okay. You can use even that table also, variable column name also. Of course, again it will go for Kruskal values when you go for the, if you select the group of num, since it is having the 3 categories, it will by default go for Kruskal values only, because in grouping number also we are having 1, 2, 3 groups. Okay, so either use type it by name or by name, the output is not going to change. So moving to the next test. Okay, before this I will continue with this first, because that was for 2 groups, so T test and Man Whitney, and for 3 groups we know it is ANOVA, and the alternative for ANOVA is Kruskal values when it is for non-parametric test. So just now we have seen for Kruskal values. by that automatic way. Let us do in the alternative way also. Analyze non-parametric. Now, in legacy, we have to select what? K independent. Earlier it was 2 independent. Now we are having more than 2. More than 2. So we have to go for K independent. Okay. By automatic way too, you will be getting the answer. But let us go by this way also and see. So my score is the test. So here also you can notice, right? That group is not coming, which is in the string form. The group in the numbered form is only visible here. So grouping variable range. Here the range, it will be asking the minimum and maximum. Okay, so my minimum grouping number is 1 and the maximum grouping number is 3. Continue. By default, it is selected median Kruskal Wallis test. Okay, and you get the answer. Okay, already we have given the values as 1 as A, 2 as B, 3 as C. So we are getting the variable name, that is the grouping name ABC, and our significance value 0.000 less than 0.5 we reject. That is, there is difference in the score between the groups. But here we don't say the mean difference. We either say that the distribution of the score is different or the median score is different. Okay. So understanding here is the type of data, that is while feeding. So if I want to perform this, the ANOVA, again it will be in compare means, one-way ANOVA. So even if you notice here for one-way ANOVA, we are not getting that all options. So hence data entering in numerical form is the preferred one. Okay. The original group is not visible here. It was at least the option of independent, but not over here. So nothing in contrast. In postdoc, if you can recall the name postdoc, in that the preferred one is Stuki, and continue and okay. So first it will give you the ANOVA table where the significance value, if you see, p value is less than 0.05 because it is 0.000. See, 0.00 means it's not like 0.000. There might be still few number 0.0007, like any number can be. But generally it will give only 3 digits after the decimal. So the 3 digit after the decimal is 0. Okay. So less than 0.05. So we reject the null hypothesis. And we can say that the mean score is differ between the 3 groups. Now if I want to know the differences between which group, so we had seen the last session, we state all the possible groups A, B, A, C, B, C. So that is what postdoc. So here when we click the postdoc, it automatically creates the possible groups A and A to B, B to C. I mean A to B, A to C. So again it is less than 0.05 for both the case. So it is significant difference. But if you notice for B to C, yes, that is also anyway less, only very close, less. So that is what we had got in when we tried all the 3 combinations. Okay. So only small understanding is required. If that is there, then slowly, gradually, you can explore more. Okay, I'll wait for a few minutes. Those who are, want to try this ANOVA and K sample T test, you can perform it. Okay, so we have done with that independent sample, 2 independent sample and 3 independent sample. Okay, in postdoc, you can select Tuki is the preferred one, LSD or Tuki is the preferred one. You can see in postdoc, LSD and Tuki. The Tuki is the preferred one. So getting to the next now for the dependent sample. Okay, dependent sample. So we are asking here, did the intervention change the score from before to after? So here we add the data before after score, and in the data description it was mentioned that intervention was being taken, and we want to know because of the intervention there is any change in the score, that is change in the score from before to after. So the two way to frame, that is two way means if it is normal and if we are applying parametric test, we will write there is no significant difference, etc. Or we can write the mean difference between before and after is zero. It is, there is no difference. And when it is non-parametric test, we cannot use the word mean, we have to use the word median. Okay. So coming back to our SPSS sheet, analyze, compare mean. So that itself we are having the option of parity test. So variable 1 and variable 2. So variable 1 will be my before score and variable 2 is my after score. Right. Option nothing to select and just click on OK. So before after is the pair over here, and we have got the conclusion. For parity test, there is no need of checking any F test, etc. There is no need over there. And we are getting p value less than 0.05. So we reject the null hypothesis. So there has been a change. There is significant change uh, in the scope, okay, due to the intervention. So there is an effect in the score. So there is significant difference in the score. Let us see the non-parametric case also. Non-parametric. I am going here by the, here it is dependent means related, right? Related. So fields in test field, we have to take so now here also we have to have the data as per its requirement. Not typing anything here, just taking an automatic field and go for run. Let's see what it is produced. See here. The median of difference between the before after is 0. The null hypothesis is the standard that it has been stated. If you recall in the Excel, when we type, when we do the data analysis, it asks now hypothesized mean by default and we write 0. That is what? Okay, by default it is 0 because when it is equal and when we take that left to the one side, it becomes 0. That is what the default value is 0. We are not comparing with any number. And yes, it is correctly selected Wilcoxon signed rank test, and it has taken a decision accordingly based on the significance value. Okay, we can see in this for way also using the legacy dialog. So it is related and two related samples only. It's a similar look like that parametric, huh? If you can observe the difference, identify the difference. Similar look of parametric. Variable 1, variable 2, by default Wilcoxon, and just OK. So you will get your the result in a table, and accordingly you will make the conclusion using the significance value. You can just perform this and check. Any difficulty you may ask. Okay, so I think we can go to the next test. Friedman test. So when this is used, uh, when I want to test a type of data similar to before after, in before after we are having only two situations. In before after we are having only two. But when we have more than two time periods, like if I want to know whether there is a significant difference in the BP level of a patient at morning 8 o'clock, morning 10 o'clock, then only two observations are there. Then I can go for PAT-T test, say, because only two different situation. But at 8 o'clock, then 10 o'clock, then 12 o'clock, then 7 o'clock. So if I'm having more than two different time point, more than two different situation, then comes the role of Friedman test in non-parametric test. And in parametric test, we have the name called as ANOVA only, but the ANOVA is called as repeated measure ANOVA, which is not there in Excel, because there we have simple ANOVA only generally they go for, but it doesn't compute the complete thing, the clear set. Hence, I didn't show that the repeated measure ANOVA. So when we are having at more than two different point, when we are having more than two different time point, like here condition 1, condition 2, condition 3, and if I want to go for parametric, then the suitable test is repeated measure ANOVA. You can, and when it is based on non-parametric test, the name is Friedman test. So kindly make note of this question and the hypothesis so we can then perform and see. Okay, so let us move to the analysis part. So analyze, compare mean. You can just find mean one sample independent pair one way ANOVA. But here we want repeated measure. Okay, so that you will find in general linear model repeated measure. Okay, you will find the option over here. So here generally we use this when it is having a different time point. So here we are having condition 1, condition 2, right? So that is what okay. So this is how we go for that repeated measure. But generally when It is of non-parametric test. So I will show you that. Analyze non-parametric related, right? It is also related, na? Condition 1, condition 2, they are related sample at 3 different time point. So related, and take all that towards the left side, unwanted one, and take this condition 1, 2, 3 towards the test field, and setting nothing we are going to do, automatic. And you can see here in the last option, that is there, Friedman is there. Okay, let's check by default what it is taking. If it is taking Friedman, well and fine, otherwise you have to go manually. Yes, Friedman test. Okay, so because this is all been set, okay, it has been structured in that way. So the distribution of condition 1, condition 2, condition 3 are the same. So it's saying you have to reject it. So that means the distribution of score is different. It's differing in different condition. Okay. So it's all very useful. But the only thing is, when we compare with parametric and non-parametric, non-parametric is not that powerful because it doesn't take any assumption. But if your data is not normal, then you don't have any other option. You have to go to non-parametric test only. Let us go by our manual way also and see how the option is asking. So, K related sample, 3 conditions. Okay. Okay. So you can see the value 0.001, and here also you can see 0.001. Okay. 0.001. Here also you can check it is 0.001 only. Okay. So this is how you go for the Friedman test. You can go by either both the ways. Okay, now moving on to the next test, chi-square test. So we have discussed about this, but let us see here in SPSS. So this is one of the tests that is which is distribution free. Hence it comes under again non-parametric option, and generally it is known or used to know whether there is association between the two variables. So, and that too, it should be a categorical variable. So here our categorical variables, we are having the last two columns, that is category and response. So I want to know whether there is any association between category and response, or whether they are related. So that is what we are going to see here. Uh, you can note down the hypothesis and the question, what we are going to discuss. So let us see the step for chi-square test. So you should know which variables, yes, this category and response we are going to consider for test, and it should be of categorical type. So it is in the option analyze. So slowly you will come to know what all is available in which tab. Okay. Descriptive statistics. Under that we have to go to cross tab, because here it makes like a row and column tabular form for chi-square. Or row and column, it's up to you. You can take any one in row and anything in column. Okay. One variable in row and one in column. You can see the statistics option. Here you are having chi-square. If you can recall one more thing, correlation in Excel when we were discussing, when it is ordinal data, non-parametric, that is the correlation is Kendall. That is what you can find over here. Okay. So chi-square, okay, continue and okay. So it will create this cross tabulation, like how many numbers under no and negative response, no and positive response, S and negative response, and S and positive response. So we can see the chi-square test table. In that significance value, Pearson chi-square, that is the chi-square value, right? So that is what your p-value. So comparison part will remain same, and you decide whether you have to reject or accept the null hypothesis. You may practice that too.
एक्सक्यूज मी मैम,
Yes.
हम कैसे डिसाइड करें कि हमने कौन सा हाइपोथेसिस लेना है, H1 या H0?
एच नो वो हमको पी वैल्यू से कंपेयर करना है सर। पी वैल्यू लेस देन, सभी टेस्ट में आपको पी वैल्यू लेस देन 0.05 से कंपेयर करना है और उसी के
ओके मैम,
बेसिस आपको कंक्लूज देना है कि अगर लेस देन 0.05 है तो हम रिजेक्ट करेंगे। वो
ओके मैम,
हमारा
ओके।
स्टैंडर्ड होगा डिसीजन क्राइटेरिया।
सब में सेम रहेगा
सब
मैम।
में सेम रहेगा सर।
ओके मैम, थैंक यू, थैंक यू।
So this is finalizing. I'll conclude with what we have discussed in all these 6 days. We have learned, actual our target was to understand finally when to choose which test, because you have seen now how simple the things are with the tools and techniques, right? You are clicking the option, you are inputting the data, you are getting the answer. So your role is to choose which option I have to select. I mean, to choose which test on the data types, and that is the only thing you have to remember. Rest all thing the tools and techniques will do and perform and give you. And second thing is giving the conclusion based on the p value. This is the only two role you are having. Rest all things has been easily made struck for you, and it's available to you now. So the small things you have to just remember so that you avoid mistake and you are well to do at least with the start of a small research by yourself. Beginning you may face little difficulty. It looks little confusing. All the terms look similar, but you can note, you must have noted all the examples. You will try to compare your data set with this data set and try to uh, see, okay, I can make my data compared to this type, so this was the test, so I will also apply this test. That would be the suitable one. That is how you should be in a way now. Of course it is not going to happen, it's not a miracle to or a magic can happen in one day or in these 6 days. Practice. There are lots of resource reference book, so keep on practicing, and of course one day you all would be also able to give your learned knowledge, share your inputs to your friends, colleagues, and you can encourage others to perform the data analysis for their own data. So thank you all from my side, and lot time to Bennett sir for giving me this opportunity for this data analysis session handling for 6 days, where I could try to cover maximum from parametric and non-parametric, which is the most important one for the research work. Because many of time the few like they plan for 1 day or say 1.5 just to give a idea ki what all has to be done. But since it was on 6th day, I could show you an hands-on experience, which is what you know the difference, right? When it is a theory lecture, we have just keep on nodding the head, but when actually we have a practical, okay, then we realize the difficulties. So hope at least even 1% you are having the clarity, that is also more than enough for the 6 days. 1% also if you could do, more than enough. Slowly that 1% gradually will increase and will become as 100% one day. So thank you once again the participant for your active participation. I'm very happy that if you could perform along with me and raise your queries and clear the doubts, happy to that. And over to you, participant. Few minutes more. If any doubt, anything you want to ask me regarding this, now the window is open to you.
So thank you so much. Uh, Tomorrow onwards, we'll be having a different resource person.
So thank you everyone. I think there is no questions in the chat box, and thank you for your kind words, everyone. Thank you so much. Yes, thank you so much. So there is no more queries in the chat box, so we can end for today. So thank you everyone. Bye bye.